am Likhitha H. Welcome to Code to Create channel. Before getting into the video, if you have not already subscribed to my channel, please subscribe to my channel. Please do watch the video till the end, and if you liked it, please like it and share it with your friends. Friends, if you have any comments, please do comment below in the box. Let's go for it. In this video, we're going to see how to predict the DNA sequencing. So can you see, I hope you guys can see this over here. We have the confusion matrix. This is going to be our end value. So basically, do not worry about the code. I have already put it in the GitHub, and the link of the GitHub will be available in the description. Now let's go to home page of Jupyter. Let's say create new Python 3 and naming this as DNA sequencing. Let me just make this as capital. DNA sequencing. Yeah. So first and foremost code that we're going to do is we have to import our necessary, the necessary imports like that are needed for us currently. So I'm going to say import, we need numpy. I'm saving it as np, and I'm going to import pandas for reading the file as pd, and I'm going to import matplotlib dot pyplot as plt, and I'm going to put a percentage symbol matplotlib inline. So let's run this. And next I'm going to say human data. First, before writing the code, please do download it. Download the data from the GitHub itself. There I have uploaded. And so I'm going to say human_data. There basically their data is going to look like, just give me a minute. Yeah, so you have the chimp data, and you have the chimpanzees data, you have dog data, you have human data. Okay. And you have to first download all these three, then copy the path, come here, and then we're going to say pd.read underscore table. Here we have to put r, it's must. That's because it's just it's just an error. Okay, let me just show you guys. I'm gonna paste this up. / human code data.txt. Let's run this. You see, it shows you a syntax error that says Unicode error. So just you have to convert it to a raw string. That's done. Okay. And then now let's just print out the head of it, the human data's head. So let me just show you. It's gonna be so confusing, so you have to have a bit of domain knowledge of what you're doing. It's gonna look like this. Basically, this is the code that that doctors use for knowing the DNA sequence. And next what you're gonna do is, it's gonna be so confusing for us to learn it and present it to other people. So I'm gonna make a bit of change. What we're gonna do is, first we are gonna take the chimpanzees data also. So I'm gonna say chimp data is equal to pd.read underscore table, convert it into a raw string, paste it up, / this is the chimpanzees, so I'm gonna say chimp underscore data dot txt. You're supposed to put it as txt. And the same way you're gonna put the dog data also. Okay, what's wrong? Yeah, sorry. Let me just delete all the iteration, else it's showing an iteration error. Yeah, now let's say dog underscore data. Dog underscore data is equal to pd.read underscore table, and you're gonna put the raw string, the code, and slash dog underscore data dot text. You're gonna say txt and not forget to end it up. And then I'm gonna print both head. First here, let's just put the chimpanzee's data as head. Now let's run it. Yeah, and now let's put the dog data as head. And now let's run it. So you got both of their heads, so that you can, for the confirmation. And next here, what the thing I have is, I'm gonna just display image for our convenience. I'm gonna say this is basically the photo image that I wanted to show. I have already downloaded it. So let's just copy this up. There's no change over here. Okay, let's just paste it now. And now I'm gonna run this. So you see, this is the gene family. I don't have, like, I just have the basic domain knowledge of it. I don't have much. And next what I'm gonna do is I'm gonna say def. It's just, you say def for representing a function. I'm gonna say def get kmers. So I think you guys don't know what's kmers. It's basically like when this is the code for the doctors. And so here also basically we're gonna just convert the data into our language that we'll know. So we're gonna say def get kmers. And then what we're going to do is we're going to say sequence, comma, the sequence, this are just the, features kind, like, they're just kind of that are included mainly here in this function. So I'm going to say set size to 6. You can set things, not everything. And then what we're going to do is we're going to return the sequence, the range. You're going to just convert it. So we're going to say return sequence. And in a parentheses, let's put x is to x plus size. This is just the formula to know it. This is just the formula, and we're gonna say dot lower. We're gonna say dot lower. And then we're gonna come out. Okay, there's no need of coming out. I mean, you have to stay in. Sorry for the confusion. I'm gonna say for x in range of length, and the variable for sequence. There's no variable. And then we're gonna say minus size. Minus size plus 1. This is the formula. This is just a function, just write down this, you will get the formula out. And then you're gonna say human underscore data in words. Say words is equal to human data dot apply lambda. I think you guys have learned lambda in college or somewhere in school. X get, I'm calling the function now, kmers. I'm calling the function. I'm going to say get kmres. I'm going to say get kmres, lambda dot get kmres. This is basically you're going to get the lambda of this x. You're going to get kmres, and within another parentheses we're going to say x sequence. Here it's basically about we're going to draw a graph. Axis is equal to 1. We're going to draw a graph. So let me do the same. Okay, let me just show you. I'm going to say human underscore data is equal to human underscore data dot drop. You're just going to say drop. It's not going to completely drop, but when you need now, for now it's going to drop. And then we're going to say, okay, let's come out of here. And then we're going to say axis is equal to 1. Yeah. Let's do the same. So I'll just copy it as we're doing the same thing. And here, let me just delete up. Yeah. And let's run it. It's running. Okay, it's saying get kmres is not defined. That's because here mine is small k, and here where I have done is it's gonna be big K. So let's change this up. KMRES, yes. Sequence. Okay. I don't know why is this not defined. Sequence. It should work. Okay, let me just do one thing. It should work because here it's gonna work, then there it's gonna work. So I think it's my internal error. Let me just paste. There might be one. Okay. I'm so sorry for this error, but this is normally not gonna come. I don't know why has it come. So let's do that. Sequence is not there. Okay. Have not even missed a single piece of code. Head. I'm gonna initialize the doctor head. So I think here somewhere it would have been error while I would be writing the formula. So let's just convert this. Let's run it. Sequence. I don't know what's wrong. Let's just do one thing. Okay. Let's first make this as K. Let's run it. Something has gone wrong. 1x is equal to 1 sequence. Let me just copy this somewhere over here. Here only it would have been wrong. Yeah, there is no mistake in the code too. You guys can see I have imported every single stuff. I don't know what's the mistake. Let's just put the dog drop over here. I think there's a bit of space mistake or like something like that. Might be some internal error. No, it's saying that it's not there. Sequence is not there. Let's do one thing. Let's just do Control X. Let's come up here to Control V. There everywhere sequence is working, but here it's not working. There might be some error with okay. Let me just copy all of these. It might be some internal error that's not working. You guys do not worry about the code. If there's any error, I'll just show you guys. There's not going to be any error, and I don't know why is it showing an error. Okay, let's just first put this up. It's gonna show an error else. Yeah. Now the image, that should work. It's still running. Let's just check. See, you guys saw, I think. There is not gonna be any error. There's some internal error with my downloadings over here when I use it double times. And then we're gonna say human underscore data dot head. I have uploaded this code which is there over here. And after that we're gonna say human underscore text. This is another variable. We're gonna say human underscore text is equal to list of human data and words. This is basically for the converting and everything. So I'm gonna say for item in range. Say for item in range length human underscore texts. This is basically just a variable, so let me just copy it. I mean, it's not the variable, but it's a for loop. That's not so important, but that's needed. It's not the main, but yeah, and then we're gonna print it out. Yeah, and after this is complete the code. Like what we are gonna do is we're gonna basically split this. So the word is gonna be like this, ATAZ. What we are gonna do is first thing we're gonna do is, okay, let me just show you in an empty cell. Let's take it as ATGCC. See, let's just take it as this. Okay, let's add a bit more. CAA. Let's just keep adding. This is mine. I'm just predicting it. I mean, not predicting, but to say, I am just showing you guys how it works out. First, it's gonna print out this, and then what it's gonna do is it's gonna leave one. It's gonna make everything ulta and everything like AAGGCCGTA, and then what it's gonna make like every ways, and then what it's gonna do is it's gonna leave one. So first it's gonna leave this A in the main one, so it's gonna leave this A. So it's gonna be just TGCCCTGAA, and then what we're gonna do is we're gonna leave T also. If we're gonna leave T, it's gonna be GCCCTGA, and then we're gonna say CCCTGA, and then we're gonna say CCTGA. So it will go on till it ends. It will like convert. It's a part of converting, and then it forms like this much. It forms this much, and then what we are gonna do is there is another. This is just for the eye locking, like for for the index of it, and then we're gonna come down. We're gonna come down. We're gonna print out the Y data. I have printed it. No, that's the human text. It's confusing, kind of confusing. It's an array. Y data is an array. And this is also basically just converting. So let me just show you guys. Let me just copy this. So because it's gonna be easier to copy and paste, and you guys also have it, but please do understand basically why are we gonna do this. That's the main point of this video. Run it. Here we are gonna convert the chimpanzee data and the dog data, and here we're gonna we're gonna fit it and transform the data. You can see here, you can just see transform, and yeah, let it just complete transforming. So the main, the main code is gonna be is when we are gonna import sklearn.metrics, we're gonna import code, precision score, and everything. I'll just show you guys. Just let this come. Yeah, this is completed. Let's come here and run this. Yeah, this is perfectly fine. And then we're gonna say human underscore. We are gonna just plot a bar. So let me just show. This is the syntax of bar. The human data's bar. You guys can see. This is the DNA sequence, and these are the names like the class. Do not this bar is basically just for checking it out. Not just care it that much. Yeah. Let's run this. You guys can see these numbers you can see in the y-axis. These are the DNA sequence, and this is the names. Basically we can just name it as anything, but in the image we have taken as 1 2 3 4 5 6. That's why. And then what we're going to do is we're going to import we're going to fit this up. We're going to fit this up. So let's paste it. Yeah, so we're going to fit this. So after we fit, we're gonna print the, let's just print for our confirmation the x train and x test. So I'm gonna say print x dot train dot shape and print x dot test dot shape. This x is gonna be a big one. Yeah. Let's run it. It's saying train dot found. Okay, it shouldn't have shown this. It's right here. Train split. I think we have to rerun this. Saying train not found. It's perfectly found. I think there's some syntax error. Yeah, I think there was some error. Let's just check it out now. This is a small x. I've told you there are a lot of things like this. Like you basically get these kind of errors very commonly because of your just silly mistake. It's x dot train dot shape. Let's run it. Oh, there's another spelling mistake. I don't know what's wrong with this. Now let me just print this. It's gonna work proper. There's some internal error. I think you guys can see. You guys saw it also. I'm sorry, but I can't do that. There's some mistake like with my data. I have uploaded the exact data for you guys. My data is like old one, so it's not gonna work. I'm gonna say, yeah. Here what we're gonna do is we're gonna import naive base, and here we are just fitting it from the classifier, and then we're gonna predict the y test. Told you guys, we're gonna predict the Y test. Control V, run it. And this is not, that's it. This is the main one. Basically what we're gonna do from here is we're gonna import sklearn, accuracy, F1 score, precision score, recall score, and we're gonna print confusion matrix. We're gonna say that we're gonna print this out, and we're gonna say name is equal to actual. We're just printing this up. And here comes the main one. We're gonna say get metrics. This is basically a function. You can see def get metrics. We're gonna take the Y test and Y predicted one. We're gonna take the actual value and predicted value. We're gonna say accuracy is equal to accuracy underscore. You can see here accuracy is 98.98. We took the accuracy. Yeah, and we have weighted this up and everything. This is just basically the confusion matrix that's having the accuracy score, the F1 score, the precision score, and the recall score. And let's run this. Yeah, so let me just copy this same thing and show you guys that it's gonna work. And yeah, so F1 is equal to 98, and these are the values. These are the actual values you can see here. The 99, 104, 178, 124, 143, 51 to 63. And the errors, there are few errors here. That doesn't matter. So yeah, now you know how to predict, the DNA sequencing. That's great. Thank you friends. Bye bye.